All right, so we're looking at negative x squared plus 16x, and it's asking you to express f in standard form. And obviously they're meaning then when they say standard form, they're kind of doing what our textbook stated, but basically we want the form that's going to show you what the vertex is, right? Okay. So all we have to do here, I'll show you two techniques you can use. But if you're a person that wants to use the completing the square process, okay, the first step of completing a square is to divide everything by your a coefficient. My a coefficient is -1, right? So divide everything by -1. So it gives me negative f of x is equal to x squared minus 16x. Now I'm going to add to both sides this half of this term squared. So half that term would be 8, right? Squared gives me 64, so I add that there. I add that over here. That now gives me this right-hand side to be able to be rewritten as x minus half of that term. So x minus 8. And I'll square that. There we go. And then it gives me 64 minus f of x, right? Now I'm going to take that and solve for f of x. So negative f of x is going to be x minus 8 squared minus 64. But I don't want negative f of x, I want positive f of x. So I multiply everything by negative, so it's going to give me negative x minus 8 squared plus 64. You see, they use the commutative property, you write the 64 out front and write it that way. I don't know that you would ever write it that way. Most people don't think about writing it that way. But that's one option. The other option, which is going to produce the same thing, is to use x equals the opposite of b over 2a, because that is going to give you the number that needs to go right there. Okay, it's going to give you that. So the opposite of b would be 16, or negative 16, right? There's my b, so negative 16. Over 2a, well, 2a would be negative 2, and it gives me now 8, right? Okay, so that is the x-coordinate of my vertex. X-coordinate of my vertex. When I plug that back into f of x, which is equal to now to, I'll write this in blue here, negative x squared. Well, x is now 8. Okay, so negative is not getting squared, right? That make sense, everybody? And then plus 16 times 8. Well, negative 8 squared is negative 64. Okay, now 16 times 8 is, well, 16 times 4. 64, so 16 times 8 would be double that, right? It would be 128. What's negative 64 plus 128? 64. So the work we just did right there, guys, tells us that our vertex is located at 8, 64. Is that okay? Well, if I wanted to take that and write in then this, what they're calling standard form, or what we call vertex form, I would say, and I hate this because I run out of room, but f of x is equal to a and x plus h squared plus k. That's the form, right? Where h and k are the coordinates of your vertex. So this 8 can now move to 0. So this is relating to zeros. If I'm on my parent function 0, 0, right? 864 is a corresponding point for my parent function that gets moved over 8 units and then up 64 units, correct? So if I move to the right 8, what does that have to be right here? Negative 8. Okay, so we have a and x minus 8 squared. And if I move up 64, it'll be plus 64, right? Now, if you were to expand that, okay, and here's the thing, I don't know what a is yet. I've got to have that a in there to make this thing kind of work. If I were to expand that, I'm going to have x squared, okay, minus 16x plus 64 plus 64. Why does it match up to this, right? Because my a coefficient, if I expand this, is positive 1. Well, what does this have to be out here then to counteract that? A negative 1. And now if you go, that's a negative 1. If you were to go through your order of operations and expand that, you're going to get back to what you started with here. So it shows you that you've done it right. But at the same time, if we've done this 2 different ways, is that there match up to that there? All right, so it shows you that it's fine to do. Now, that being said, guys, is it a different process? No, because the x equals the opposite of b over 2a is a formula that is developed based off of completing the square. So either route is still completing the square, it's just maybe a little bit quicker, I think, using opposite of b over 2a. All right. So the next thing it asks is to find y-intercepts or x-intercepts. Okay. I'll find y-intercepts first because that's easier. Okay. And it doesn't matter, guys. The function that you use here. Okay. If you understand that a y-intercept is when x is equal to 0, right? You can plug 0 in here and evaluate. But doesn't it make more sense to plug 0 in here and evaluate? What do I get if I plug 0 in here? I get 0. When x is 0, y is 0. Okay? Now, finding the x-intercept, that's fine. And we're talking about this a little bit more today. But finding an x-intercept is simply factoring. It's coming up with where this thing is equal to 0. Now, you can, again, do either one. You can do this one. Okay? Subtract 64 from both sides. Gives me negative x minus 8 squared. Divide both sides by negative, so that goes away, right? Square root both sides, so that turns into an 8. And this becomes x minus 8. Can I add 8 and get 16? Can I, and this would be plus or minus, so I apologize for that. Can I add 8 to the negative 8 and get 0? So you see that my x-intercepts are 0, 0. Okay, because the y value has to be 0 on x-intercepts, right? 0, 0, and then 16, 0. Okay? The vertex we've already found as being 864. Now, that's fine doing it that way, but I think that's more algebra, that's more work. Isn't it easier, at least for this one, because there's no c term, to factor that thing? 0 is equal to negative x squared plus 16x. What do they have in common? Okay, you'll take a negative x out, that's fine. So you get negative x, so that's going to be x minus 16, right? Well, that's a product. So that means negative x is either 0 or x minus 16 is equal to 0. So they give me x to be 0 and x to be 16. Okay. Now that's just having the ability to recognize I have two formats of a function to use, and doing a little quick foreshadowing, maybe a 2 or 3 second analysis of both functions. Say, okay, which one's going to lead to maybe a quicker set of x-intercepts? Okay. Make that decision and then go with it. That help? I think what some people do with questions like this, because I think all the examples we did had a C term in it. Okay, and they see this. Well, it doesn't have a C term. I don't know what to do. It's actually a simpler problem because there is no C term, guys. But if you want to put a plus 0 in there, do it. Okay, and then maybe you can kind of work through using that C value to help you out. Okay, I think a lot of times when the question gets simpler, because in class maybe we're doing the more difficult kind of rigorous type questions because we're having more terms. When they take terms away, it doesn't look the same, so people get confused. All right, try to combat that a little bit. Megan? Say 2 or 3. Seeing it? This one?
There's one that's like on the.
Okay. So finding. All right. So if we go, let's put this in vertex form real quick. So x is equal to the opposite of b over 2a. So x coordinate is 1. If I evaluate this at 1, There we go. 4, 1 squared minus 8 times 1 minus 3. So that's going to give me 4 minus 8 minus 3 gives me negative 7, right? Okay. So my vertex is located at 1, negative 7. So this thing is going to look like f of x is equal to some a value. Now it's going to be x. Now what is it, plus or minus here? Be minus 1 squared, then minus 7, right? Now if I expand that, do I get a 4 right away when I expand that stuff? No. So what's this a got to be? A's got to be 4, right? All right, so that is putting it into that standard form. I don't know if they asked that, but the next thing they want is the y-intercept, right? Well, doesn't it make sense to find the y-intercept right here? Y-intercept is going to be what? X is 0, y is negative 3. Okay, and that's something to pay attention to, guys. On tests, I will know what you mean. Okay, but the rubric that I get a lot of times from Rhodes, or when I teach at Rhodes, or even when I was in college, if they ask for the y-intercept or the x-intercept, that's a point, correct? If you write it as just one value, you just wrote negative 3, a lot of professors are going to give you grief for that. Might mark points off for that, okay? Understand your intercepts are points. Finding the x-intercept, then, the idea is this thing's got to be equal to 0. So we go through and say, okay, can I do the AC method? It gives me negative 12. I think about numbers that multiply together, give me negative 12, and now it's giving me negative 8. There are no factors that do that, right? Okay, so the AC method doesn't work. If the AC method doesn't work, we're kind of down to our last option, and we have to use what? Quadratic formula. So if we're going to use quadratic formula with that, that's fine. My suggestion is if you've already done all this work, that means you've done a majority of the quadratic function or quadratic formula, because the quadratic formula is determined, it was derived from completing the square, right? Well, right there, we've done most of the completed square process. So we're going to add 7 to both sides. We're going to divide both sides by 4. I get that, right? So now what do I do in order to solve for x? Take square root. So when I take square root, guys, now I'm introducing the square root, right? So when I introduce the square root, I got to have the plus or minus. So it gives me plus or minus 7/4, plus or minus root 7/4 is equal to x minus 1. So now what? Add 1 to both sides. So those are the exact answers. But when they want you, if you go back down to the direction, you said it told you to round it to a certain decimal. Round your answers to 1 decimal place. Yeah. So you would just type in 1 plus root 7/4 and round that. 1 minus root 7/4 and round that. Doing that around because it changes things. If I round, 2.3 is not 1 plus root 7/4. Does that make sense? So then if 2.3 is not that 0, then that curve really isn't 4x squared minus 8x minus 3. Then if I'm using those rounded values, does that make sense? That's my issue, my concern with rounding things, is because then we really don't have the zeros or the information that we're looking for that particular function. Okay? We're close, we're in the ballpark. But I think rounding, I would have rather them actually leave it this way. I'll probably actually leave it this way on the test quiz. That help? Let's